This is HSPS 1-6, the Chemical Changes and Reversibility module, and the first thing to go over here is the engage. The first thing is the nature of science and the engage. The engage's nature of science is that they are asking questions and observing a phenomenon, much like scientists do, to actually ask questions and develop which ones they want to answer. The formative assessment through answers is what teachers will be able to do to understand where students are developmentally in this process. The model of learning that the step of learning that they will be doing is assimilation, where they are taking in the videos of information and deciding really where to go with it. And then they will address the idea of reversibility for their DCI. So the DCI is those chemical reactions, and the idea of reversibility within those chemical reactions is going to be the first thing in the engage. Then the reflection for me is that the hardest part was to get really all three of these three concepts together. And as you can see here, didn't quite succeed getting all of the CCC and SEP into the engage section. And now we can move into the idea of what they will be doing for their Explorer. With the Explorer, we see that their nature of science is an actual exploration into the labs that they will be doing. Their labs will then be formative assessments to be able to answer those questions and really understand what's going on. The idea of disequilibrium will be seen in these students because they will have to see new information they hadn't thought about and really work with it in their um, in their labs. They'll have to be doing labs and answering questions about those. And the DCI there really is the chemical reactions, simply because they are performing chemical reactions, and in that using that they can follow the CCC, those the cross-cutting concepts of changes. And so then they can use the lab as a model of reversibility for going forward that addresses the science and engineering practices of it. And the hardest thing for me about this particular stage in terms of the 5 E's is the actual integration portion of the three dimensions, because it feels a little bit hard to integrate them. Moving on to their explain, the nature of science here really is using models. Scientists use models all the time to explain things, especially on the molecular level in chemistry, that they cannot see. And really, the way that teachers will be able to know setting they're in, what level of knowledge that they're in it developmentally, is their idea of formative assessment in what these models actually look like. The organization is what these students are doing, because they've learned all of this information through the labs, through everything else, and now they have to actually organize it and be able to communicate it to the real world. The DCI is the fact that they have made now a model of reversibility, a model of change, and what for those CCCs, what those changes and causes of those changes can be, and how we can pull something that is stable into a state that is changing. Then you get to the idea of the SEP, the actual model development. This is SEP number 2, and that the entire SEP for that one revolves around the actual model building, which they have done. Now, the biggest challenge for me is really that piece about how the SEP should really be evaluated. How can we tell that they've actually developed a model that represents their own understanding, and what components do we decide are important versus what are a little bit more esoteric? So this is really when we start to get to the elaboration phase, where we see the nature of science is really made in those connections to new phenomenon. So when we give students another phenomenon, what we really are showing them is that science is interconnected, it's cyclical, it can be applied to new things, and you can find out new information from there. Developmentally, we can assess those connections formatively as teachers to be able to see that these students are where we want them to be. The students will then have to be using their accommodation and organization skills where they have to accommodate all this new information and now organize it in a way that they can use the new information. The DCI is again chemical reactions, and now they've moved from chemical reactions outside of the body to chemical reactions inside of the body, looking at the blood buffer systems. And then they get to their CCC, where they understand now stability, where we can put things into our body and it's not going to change immediately. And then, so this gets into the idea of the stability versus the change aspect. We focused in the explain and explore on a lot of the changes, and now we can focus on the stability. And the SEP is again another model, but this time it's going to be a model of those factors that are present in a human body. So how the blood system works to buffer out all of these. And again, with this, the biggest challenge for me is that integration piece of making sure that the DCI, CCC, and SEP are all integrated so that it doesn't feel choppy between it, so that students can actually enjoy it. One of the things I do like about this, though, is that it does become a very relevant example. Students are always eating and drinking something, and so, that's not something that they can avoid thinking about. So here's our last stage of the evaluate portion. The evaluation is really based off of the communication of information that's present in scientists all of the time. Scientists are always communicating information, and that will really help them to get to this to new questions, and that's part of the nature of science itself. The final evaluation will be a summative assessment of the students in terms of making sure that they've gotten all of this, and that comes from the students being able to organize mentally in that scheme of organizing all of this new information into coherent ways of communication and really being able to show that they understand that. The DCI for this is chemical reactions, and that is exactly what they're using. They're using chemical reactions to explain reversibility in terms of stability and change, and they're using a model to explain all of that. The hardest thing about this section was the actual development of a rubric itself that was comprehensive enough to meet to show students exactly what I want them to get out. And voila, that's it.